All right, Trig class, we're going to be looking at section 4.3 in this lesson, and we've been, in the previous two lessons, we've looked at graphing sine and cosine functions. Just the second lesson was, it had vertical and horizontal or phase shifts within graphing these functions. This one is going to have, I'm going to be showing you how to graph tangent and cotangent functions. Just like sine and cosine, they have the sine and cosine functions had the similar pattern, had that wavy pattern to it. These two functions have a very close look on how they also look. So let's go ahead and get started here. Okay, so from college algebra, if you remember that we studied something called vertical asymptotes, and a vertical asymptote is a line on the graph where at that certain x value, it does not exist. So we have asymptotes in these two equations, tangent and cotangent functions, because if you remember, tangent of some angle is equal to sine of that angle over cosine. If cosine function, if that value is 0, then we are going to have a vertical asymptote at that certain value. So we are going to have vertical asymptotes to graph in both of these tangent and cotangent functions. So let's take a look at what they look like. Here is what a tangent graph will look like. Um, and here is what your graphs are actually going to look like over here. Many times I'm going to only ask you to graph one period. And remember, how I explained a period is one portion of the graph that repeats itself over and over. So this right here is one period. And then it repeats itself over and over and over again in the positive direction and in the negative direction, and it goes on forever in either direction. So these values that you see that are not here, those are your vertical asymptotes. And these tangent and cotangent graphs have several vertical asymptotes. They are infinite amount of vertical asymptotes in our graphs on here too. All right, so the domain of our function is this right here. It's our, for all x values that are not equal to this right here, where n is just some integer number. And then this right here is our range. Our range, remember in sine and cosine functions, the highest value was 1, the lowest value was -1. Unless we had a different amplitude, then it changes the height and the lowest point on the graph. But here, any tangent and cotangent function actually are going to have the range of all real numbers. All right, so your tangent function, f of x equals tangent of x, are going to have these properties about it. So the graph is discontinuous at values of x of the form, this right here. So that's how you're going to actually find your vertical asymptotes, are using this fact right here. And then another property is that the x-intercepts are of the form this here. So that's going to help you in finding all the values where it crosses the x-axis. And its period is pi. Remember, the sine and cosine functions, your period, it was 2 pi. But for tangent and cotangent, it's going to be pi. Now, its graph, we don't have amplitudes to find since there are no maximums or minimums, because you remember it has all real numbers. It's infinite in the negative y direction and the positive y direction. So no maximums, no minimums. And then the graph is symmetric with respect to the origin. So the function is an odd function, meaning this right here. Remember, all odd functions have this property about it, that the tangent of your negative x is equal to the negative of that. Or in other words, remember, odd functions are this. When you plug in your negative x and it's equal to negative f of x. And that's telling the same thing right here. Okay, some of these things are important in graphing your tangent functions, but some of them are just some facts in here that I threw in. Okay, for a cotangent function, your domain is going to be all x values such that x is not equal to n times pi, where n is just an integer, any integer. And that's going to help you in finding your points of discontinuity, your vertical asymptotes. And then your range, again, all real numbers. All right, so let's get into graphing some things. Yeah, we'll look back at this here in a little bit. The discontinuity values are going to be of this form. This right here was supposed to be pi. I don't know why I had that. It's pi, and this was also same thing. The period for a cotangent function is pi. Just if you notice from one of the previous slides that looked like this, except it said tangent here, this right here and this one right here have been switched. Okay, so this is how we're going to find the x values that where our vertical asymptotes lie. This is going to help us in finding our x-intercepts. All right, so these are guidelines for sketching graphs of tangent and cotangent functions. We're going to be using these 5 steps every time we graph one of these types of functions. So just like the sine and cosine function, start out by determining the period. And this is going to be how you find your period this time. Since one full period in a tangent function and a cotangent function is pi, instead of it being 2 pi over b, you have pi over b. And then it says to locate 2 adjacent vertical asymptotes, solve the following equations for x. So we're going to be using this right here and this right here and solving for x. And that right there is going to get us our 2 vertical asymptotes for one full period. That's for a tangent function. If you have a cotangent function, one of your x values or vertical asymptotes is always going to be at x equals 0 unless we have a vertical shift, a horizontal or phase shift that we have within that function. And we'll look at the phase shifts here after a while. So sketch the 2 vertical asymptotes found in step 1 after you find those. And then you divide the interval formed by the vertical asymptotes into 4 equal parts. And then you evaluate the function for the first quarter of points, in the midpoint, in the third quarter, and then after that, you join all the points with a smooth curve. And remember, at vertical asymptotes, make sure it's approaching that vertical asymptote on either side of your graph that you are graphing for your tangent and cotangent functions. All right, so let's look at an example. All right, so we are asked to graph this tangent of 2/3 x function here, and if I'm only going to graph one full period on these tangent and cotangent functions. I don't believe your book has asked you in this section to graph the of two full periods or any more than one. But if it does, I will show you in class, okay? Just remind me to show you how to graph the second period of a tangent or cotangent function. But go ahead, let's go ahead and get started. We're going to follow the 5 steps that we just reviewed. And it's so for the first step, it says find the period and locate the vertical asymptotes. So finding the period of this function, remember it is equal to pi over b. And your value of b is just like in your sine and cosine functions, it's what's being multiplied to your x value, so 2/3. So this right here, multiply it by 3 over 2, the reciprocal of this, and you get 3 pi over 2. So there's your period. And for finding locating the vertical asymptotes, remember, go back to this right here. These two equations are going to help you in finding your two vertical asymptotes. So let's see, bx equals negative pi over 2 and bx equals pi over 2. So solve using your b, which is 2/3, equals negative pi over 2. And you also need to solve 2/3 equals pi over 2. And then you, oops, just need an x in here. Now solve for x. So multiply both sides by the reciprocal. Same goes on this one. Whoops, 3 over 2. And now this gives you x, and you have, let's see, negative 3 pi over 4. And then on this one, you have positive 3 pi over 4. So this right here is your full period for this tangent function. This is going to graph one full period. This is one of your vertical asymptotes that you will show on a graph with a dotted line, and this is another one. Okay. All right, so I went ahead and copy and pasted my graph in here with the vertical asymptotes drawn in already. So what you see here in this pinkish color, this is negative 3 pi over 4. That's one of your vertical asymptotes. And then positive 3 pi over 4. That's the other vertical asymptote. Now we're going to, what we're going to do is divide the interval, this right here, between our vertical asymptotes into 4 equal parts, just like we divide our period up into 4 equal parts for our sine and cosine function. We're going to do basically the same thing here. So for this here, we're going to say for a tangent function, the value that is going to be exactly in the middle of these 2 points here is going to be 0. Okay, so that's one of our values. And then so we need this value that's going to be halfway between negative 3 pi over 4 and 0. So average the two, okay? Or just divide by 2 in this case. And what you will get is this here. 3 pi over 8. Do the same thing here. Halfway between 0 and 3 pi over 4 is this value divided by 2. So it's going to be 3 pi over 8. Okay, halfway between about here is 3 pi over 8. And here, this is negative. Okay, so after you've split your interval into equal parts, we already know that these two values on the end are your vertical asymptotes, which should already be graphed. And then we just need to evaluate these 3 points. So if you don't know what the pattern of a a trig function like tangent or cotangent looks like, then just plug these values into your calculator. Take your function, tangent of 2/3 x, and like I told you in your sine and cosine functions, plug these in as x values into that function. So here I'm going to write that down. Y equals tangent of 2/3 x. Okay, so plug in the negative 3 pi over 8 into x and evaluate that. And let's see, what we're going to get is, for the first one, we're going to get y equals -1. And for 0, we're going to tangent of 0 is 0. And then plugging the 3 pi over 8 into your tangent function here will get you 1. And this is often the pattern that you will find whenever you are graphing your tangent and cotangent functions. These x values that you have found, you have broken up into equal intervals. You're going to find it that one of your values is going to be -1, one's going to be 0, and the other one's going to be 1. So they're just easy points to locate on the graph after you have plotted everything on your x-axis correctly, and then now find your y value for it. Okay, so for 3 pi over 8, or -3 pi over 8, your value is 1, or sorry, -1. So this, I'm going to graph it in different color. Do purple. So this value at -1, there we go. And then 0, and then +1. Okay, so what you do is now you graph a smooth curve. It's kind of going to have the shape of a cubic function, if you can remember what a cubic function looks like. So connect all of these values, all three of those values together, and then just draw a curve that approaches each asymptote. Okay, and then you're done. All right, on this function, let's do the same thing. Let's take the same step. So step 1, find the period and locate the vertical asymptotes. This is a tangent function again. So let's see. Oh, and this time, remember we don't have an amplitude, but this number right here is going to take place in graphing the values here in a little bit that we do. So the period of this function is equal to pi over b, so pi over 2. There's our period. And our equations that we want to solve are bx equals -pi over 2. So 2x equals negative pi over 2. And bx, or 2x, equals pi over 2. Now solve each of these, and you get, let's see, so divide both sides by 2, we get x equals negative pi over 4, or x equals positive pi over 4. Okay, so these are our two vertical asymptotes, right here and here. And then now let's go ahead and divide these intervals, this interval from negative pi over 4 to pi over 4 into 4 equal parts. So starting with negative pi over 4, halfway between the two, again, we're going to have 0. And then halfway between negative pi over 4 and 0, just divide by 2, and you get negative pi over 8. And then again, this interval right here, this number is going to come from half of this. So again, divide by 2 to get pi over 8. So this is a vertical asymptote, and this is 2, and these are the x values that we use to find the y values and plot on our graph by plugging these x values into our function. All right, so on this, our function, just to remind you, is 1/2 tangent of 2x. We're going to take each of these x values and plug it in for x to find the points that we want to plot. And remember, these two are vertical asymptotes, so it's undefined here and undefined here. But to find these other y values, plug x values in, and what you're going to get is, hold on, oh, it's negative 1/2, is this here. So when we plug in the negative pi over 8 into our function, let's see, we get 1/2. And then whenever we plug in 0 into our function, we get 0. And then pi over 8, we get negative 1/2. Okay, so plot those values on your graph. So halfway between is negative pi over 8, and here is pi over 8. And plot all your points. So negative pi over 8 and 1/2 is, oh, here's 1, so this is 1/2 right here. And then 0, 0, and then pi over 8, negative 1/2. All right, so now carefully, well, I cannot draw on my tablet. Let's see, I'm going to start up. Hold on. Okay, there you go. While I paused it, I ended up drawing the graph in for you. That is what your graph of your tangent function here should look like. Now notice this right here is different than what we've been graphing. This is a cotangent function. We've been graphing tangent functions in the two previous exercises. So a period, we can find that in the same way. It's going to be pi over our b. So pi over 1/2, which equals 2 pi. And then now how we find our vertical asymptotes for a cotangent function are these two equations. Bx equals 0, or Bx equals pi. and we solve for x by plugging in our value of b. So 1/2 x equals 0 and 1/2 x equals pi. So on this one, of course, x is going to equal 0 on this, and then x is going to be equal to 2 pi. And now that we have our vertical asymptotes right here, those are the ones that we're going to plot on our graph. All right, I've gone to a new page where I have already plotted on my graph here the vertical asymptotes. And now we have to split this interval up into 4 equal parts. So splitting this interval up from 0 to 2 pi into 4 equal parts. Well, if we start at 0 and then go to some other number, this right here, remember this is how we did sine and cosine graphs. We split from 0 to another value up into 4 equal parts by doing this thing right here. So we'll take 1/4 of this value, 2 pi, then 1/2 of it, and then 3/4 of it, and then you're back at your 1 full period right there. Okay, now do the math for this, and you get pi over 2 pi, 3 pi over 2, and 2 pi. Now these are your x values that you need to plug in to your function up here and find your y values for. First one is going to be undefined. That's your vertical asymptote. Plug that in, and what you should get is, let's see, you're going to get 3. And then the next one, you're going to get 0. And this one, you get -3. And then this right here is your vertical asymptote. It's undefined. Okay, so plot pi over 2, 3, pi, 0, and 3 pi over 2, -3 on the graph. And right here, this value is pi over 2, and this is 3 pi over 2. Okay, now we are going to plot pi over 2, 3, pi, 0, and then 3 pi over 2, -3. Oops. Okay, and then it looks like a lot like the tangent curve that we graphed in the tangent exercises previous to this. I'm going to pause it and you'll see what the graph looks like. So drawing a curve up in this direction, remember the vertical asymptote is what it's getting closer and closer to. It will never cross this asymptote. Same goes on this side of our graph. As we go downward, it gets closer to the asymptote, but it will never cross it. Okay, so make sure your tangent and cotangent graphs of your functions that you draw in do not go beyond those 2 vertical asymptotes that you plot on your graph. This example here, I just wanted to briefly discuss. You're going to graph a tangent function that has a vertical shift on it. That's what this -3 is on your function, is a vertical shift. And this is just a regular tangent function. There's no change in the period, and there's no phase shift on it. It's just tangent of x. It's going to look exactly like a tangent function, except this vertical shift causes it to go down 3 units. So just like graphing your sine and your cosine function, you're going to shift everything down 3 units, or how many ever units your shift is. and then draw that vertical line, sorry, horizontal line, and then plot those same x values and corresponding y values on your graph and draw your smooth curve between your vertical asymptotes that you have. All right, on this last example I have for you, it's a cotangent function, but it has a vertical shift and a phase shift. So I didn't want to completely skip over it or not talk about, or just talk about it with you like the last one. Uh, this right here is going to cause us to do something a little bit different than what we have been doing in the previous few exercises. So just as before, find the period of the function. Period is going to be pi over our value of b, which is 1, so pi. And then to break this down into, let's find the vertical asymptotes. Well, vertical asymptotes for a cotangent function are normally this right here, bx equals 0 or bx equals pi. And you plug in your value of b. Well, since we have a phase shift, what we do is we actually can do this. Take what's inside our cotangent function, which is that, and then we set it equal to 0 to find one of our vertical asymptotes. And then same thing goes on for the other vertical asymptote that we want to find for the graphing one full period. So set it equal to what's inside your parentheses here. Set that equal to pi. And then solve for x. So here, solving for x, not so bad. Subtract pi over 2 from both sides, we get that. And then for the other one, if we subtract pi over 2 from both sides, we get pi over 2. Okay, so now these are two vertical asymptotes that we are going to plot on our graph. I'm going to do that on the next page. All right, so to be able to plot more points on your graph after drawing in your vertical asymptotes, remember we got to split our interval between our vertical asymptotes up into fourths. So halfway between negative pi over 2 and pi over 2 is going to be 0. So we know the middle value here. And then halfway between negative pi over 2 and 0, well, divide that by 2, we get negative pi over 4. Same thing goes here. It's going to be pi over 4. These are our x values that we're going to use in our function to find the values of y. So when we plug in this, it's going to be undefined. But when you plug in this for our x value into our function here, to x, we will get, we will actually get the value of 4. And then 0 gives us 3. And then this gives us 2. And then we're back at undefined. Okay, these numbers are different than the ones that we have plotted before. And that's because of our vertical shift. If you want to go ahead and draw in your vertical shift on your graph with a dotted horizontal line, so right here we're going to say it's 1, 2, 3, 4, 5. So right here is what everything is being shifted up to. And so compared on this vertical line here at our negative pi over 4 x value here, we have 4. So this point right here. Oops. And then at 0, we have 3. And then at pi over 4, we have 2. Now, if we did not have this vertical shift on our graph, if this was just cotangent of this right here, all of these values would be back down here at 0, 0, and then this value at negative pi over 4 would be at 1, and then this one would be at negative 1, just like our first function that we graphed. But this is how we graph this function here with a vertical shift and a phase shift. Now, draw a smooth curve through these 3 points. Don't just connect it like a line. Draw a curve, make it look like a tangent or a cotangent function. And there you go. I just drew a curve through everything, and that is how it's going to look. And that is actually all I have for you. Yep, that's the end. So I will see you all tomorrow in class, and have a good rest of the night. Goodbye, everybody.